are you unmuted? Let's see here. You can see your presentation. Apologies, I'm not hearing Tim. You are muted. I'll request you unmute.
There we go. Can you hear me?
Yeah, we can, and we can see your presentation.
All right, thank you. Yeah, I was hoping that would work. Thanks for the introduction. My name is Tim Thompson, and I work on the user space part of our software stack for Omni-Path here at Cornelis Networks. With me is Dennis D'Alessandro. He works on the kind of the hardware part of the stack. That would be the HFI1 device driver in Linux. What we want to talk about today is a new Libfabric provider for Omni-Path, and kind of how it ties into the software stack that we have. So here's the standard legal disclaimer slide. This is kind of a mini roadmap of Cornelis Networks and where we're at right now and where we're going in the near term. You can see the PSM2 provider has been the way that Omni-Path was initially GA'd, the provider that was given with it, and it's really PSM2 is more than just a Libfabric provider. It's pretty much a whole kind of message layer user space API really, and so it's got a history. I think it goes before Omni-Path even. And it's kind of a different way of doing a message layer than what OPX is. And we have OPX is upstreamed and available. It's not GA'd yet. PSM2 is the current supported way of running Omni-Path. So, but I'm not sure if there's another fabric out there, or another hardware that has two different hardware providers like this. So that's kind of a unique place for Omni-Path right now. So I wanted to highlight a few things about OPX and about some of the ways that it differs from PSM2. The first thing that I wanted to say is it's really easy to switch between the two providers. You don't have to do any specific driver tweaks, or pretty much there's a tuning guide for larger fabrics for PSM2, and a lot of the information in that guide applies directly to OPX. So it makes it even easier to use. And the one thing that I did want to mention is there's one part of that tuning guide is talking about the size of the receive header eager ring. The two supported settings for OPX are going to be either 2K or 8K. So I wanted to kind of bring that out while everybody's here. But other than that, it's really kind of a drop-in replacement for PSM2, and you don't have to do any weird things to your fabric to kind of reprovision it or anything like that. So that's a pretty nice feature of OPX. I wanted to do a slide about kind of all, since there's these two providers and some other things out there, I wanted to do a slide to kind of clear up what's what. So PSM2, as I mentioned before, that is the kind of the legacy provider. It's been around for a long time. It's got a lot of burn-in on it, and it's a very stable and good provider. It also provides native GPU support. PSM2 is it's not directly it's not a pure semantic match for Libfabric, though. It's kind of its own thing, and you'll actually see MPIs when they run. You can see them tying into kind of the top of PSM2 and not going through the Libfabric interfaces at all. So there's kind of two paths into it. And PSM3 was released, I don't know when, maybe a couple of years ago, and that is it's a fork of PSM2, but I believe it's targeted against Rocky and some of the more Intel advanced Ethernet products out there. That provider is maintained by Intel, and I've never actually ran it before. PSM2 is maintained by Cornelis Networks, as well as OPX is maintained by Cornelis Networks. So just wanted to bring that up. This is I like this slide right here. It's kind of a good picture of the Omni-Path view of the HPC software stack. You can see here, as I was mentioning before, there's some MPIs like OpenMPI that can come, right into PSM2 and use it natively. CH4 and MPitch will do that too. And you can see that the way that verbs is implemented on Omni-Path, but it's done all down in the device driver, down here in this part, and very little of that is exposed to the software stack. So it does work, but it's not really widely used in Omni-Path. This is more interesting over here. This is where you can use OPX. As I said before, OPX it's a Libfabric provider and nothing else. There's no other, ways to tie into it, from a library level or anything like that. So you have to use Libfabric to use OPX, and that does work pretty well with most of the middleware that we have pictured here. We do have most of the OpenSHMEM, the Sandia OpenSHMEM test passing and pretty decent performance. OPX has a full one-sided RMA implementation, and it does perform pretty well compared to some of the other things out there. There's a few Libfabric features that we don't have implemented yet. We've pretty much followed the what used to be the MR scalable bit mask of kind of that's the whole idea that the application takes on a lot of the kind of the parallelization parts, handles a lot of the problems like say locking and like key exchange for memory regions. The app does that, and with Libfabric you can tell it either the app's going to do that or I want the provider to do that. And for OPX right now, we've focused through the scalable, high rank implementation, the features that would use. So things like MR Basic don't really work in OPX yet. In addition, the charm, I think they want to do AV table for the address vector type, but that's OPX only has AV map implemented right now. So that's another one. And when we go to GA, of course, we'll have these implemented. So that's what the software stack looks like. So I wanted to get into a bit more about the kind of some philosophical differences between PSM2 and OPX. That's mostly what we've done when developing OPX is PSM2 is there and it works, and obviously if we're going to have another provider, it should work better, right? So we benchmark on the same, and it's pretty nice because we can since it's so easy to switch it in user space, it's pretty easy to run tests with one provider and another provider on the same hardware at really close to the same time, the same, get a lot of variables out of the way. So OPX, it started as a fork of the BlueGeneQ provider in Libfabric, and the BlueGeneQ specific parts were ripped out of it, and it was rewritten from scratch with the hardware spec in one window and the code in another window. So no things were taken from PSM other than a few structures on how to map the bits and things for the device drivers, but it's pretty much a pure implementation from scratch. And one thing that we did have to add for it that wasn't in BlueGeneQ is a reliability layer. So OPX has Omni-Path is a lossy fabric, and so you have to be able to do what they call end-to-end replay sometimes. And OPX has that implemented. It basically only has two jobs, to packetize the data when it comes in and to do replays really quickly when they are needed. So it's that reliability layer is also written in two different. It can be used in two different modes, what we call the onload model and the offload model. And the onload model is what we currently are supporting and have tested extensively. And that's the idea where you don't have any dedicated hardware, reserved hardware on the rank, on the node. I mean to run overhead. you just run inside the rank. OPX will run its, reliability parts and some of its overhead and kind of, hitchhike along with the traffic of the MPI application or OpenSHMEM application. The other mode is the offload mode, where you would dedicate some resources on your node, and all of the ranks would check in and have sessions with that node level reliability layer, and it would therefore your ranks wouldn't have any would have less intrusion than they do right now. That part that was working about a year ago. We decided to go with the onload model, and we plan on getting that going, and that'll be an interesting way for application developers to kind of do some tuning and test their app. Which one might work better, for an app. It's going to be really workload specific, I think, and also hardware specific. So there's some interesting things that are still coming down the pipe uh, that we have in the works. So I wanted to show a few benchmarks. These are favorable message sizes for OPX, because right now we don't have bulk transfer going. So anything over 16K message length isn't going to perform well on OPX versus PSM2. But we did manage to hit, I think we're 990 nanoseconds for a ping pong on this newer Intel hardware right here, and that's 2 sends and 2 receives, right? So that's a pretty decent latency right there, and you can see the message counts are very good for smaller message sizes, and then as we hit line rate, we kind of equalize out with PSM2. Here's the same test done on AMD Milan, and we were able to crack 1 microsecond of latency on Milan. So that was pretty good. There's still some bias tuning and things that do affect Omni-Path on these platforms, and we have people working at Cornelis that can help customers with bias tuning and that kind of thing. It definitely has a big impact on these benchmarks. So and again, most of these are pretty small message sizes here. This is an interesting slide here. This is another when we develop OPX, it's kind of a different philosophy, really. We don't write code in, like, I would say, like like good software engineering principles say that you should layer and reuse code, and there's these design patterns and things, and we do that where possible, but really the way that we do things is we have our performance counters and our these some of these metrics right here that I have. These are generated with Intel SDE, software development emulator, and it's really, you can on a certain function stack, like through the whole software stack, you can kind of profile and see how many instructions did it take to process, say, one data, a blocking MPI receive. That's what we pay really close attention to, because on Omni-Path, the receive tends to be the bottleneck. So we really closely watch this path for performance. And so when I'm making changes to the code, I mean, I watch this like a hawk, and do not lose any instructions or clobber any more cache lines than we need to. And that when you do that, it translates. That's kind of the biggest explanation for those graphs that I had before this one. Like, how can this be the same hardware? You change one thing, how does it change that much? And this is a big reason of the root cause of that. And I just wanted to say, it's not the kind of code that I'd show like somebody that's learning C++ in computer science 101. There's a lot of, there's copying, pasting and things in there, and it annoys some programmers, but the the thing that we really gauge all of our work on is these numbers right here, and either making them better or not hurting them as we add more function. We had we have a customer that's kind of partnering up with us and running some of our earlier builds of OPX at scale. They already have this cluster's been in place for quite a while. They've ran these apps many times on it. They've been tuned, and they were seeing some really great results with apps with OPX. There's also some results that aren't so great right now, which is why OPX isn't GA'd yet. But this is definitely very encouraging. You know, we have stability at over 1,200 nodes, and you know, real world results in, you know, less wall clock time, which is the ultimate benchmark, right? So let's see. So yeah, I wanted to kind of wrap it up with where's OPX at right now? It's going to be in Libfabric 115. It's up there right now. We have a few pull requests and changes that aren't up there quite yet, but after we do our pattern is to do validation on the weekends and then push upstream first. We push upstream usually earlier in the week after a good validation. I think Libfabric 1.5, I'm not sure if it's released yet or not. I think it was pretty close. But OPX will be in that, and those numbers that I had earlier are pretty much generated with the code base that's out there. Also wanted to mention Deos. We are testing Deos. We have it in our continuous integration testing, and or at least it's almost there. And we are passing most of the tests that Deos and all of the layers below it have for bring up on OPX. So things are looking good there, and eventually it will be supported under OPX eventually. And see, OpenSHMEM, you know, works well. I wish I had some benchmark numbers, but I didn't get them into this slide deck. But we're pretty much passing all the tests on that. We're passing all the MPitch tests as well for, you know, for MPI validation. So this is what the middlewares that we're focused on that are the most important to us are kind of in order on this graph right here. You know, OpenMPI and Intel MPI. And Vapitch is currently in bring up. I think Brian Smith is kind of working on that with the OSU team to get OPX working on their Omni-Path hardware. I owe the MPitch guys a couple of pull requests to set the optimal parameters for OPX. That's one thing that we haven't upstreamed yet. There's kind of like all the MPI middlewares have their kind of like best defaults for a provider, and those aren't up there for OPX yet. So you have to use you know, a lot of environment variables to work around that. I really want to get that upstream soon. We have OpenSHMEM on there too. GPU support is on the way. Don't really have an ETA for that yet, but it is being worked on, and it also works with PSM2. So if GPU is important to you, you'll be sticking with PSM2 until we get that implemented in OPX. So
Cool.
I think that's pretty much all I had in the slide deck. I can answer questions or even if anybody had any thoughts.
Sure. We've had a couple of questions that Denny was able to answer already around IP over IB presence in the OPX software stack, and the end applications and end user of IP over IB. Two outstanding questions though. One is when you say you're testing every commit, do you mean every commit in Libfabric or every commit that goes to the OPX provider?
Just to the OPEX provider. When we do pull down commits from upstream, if a lot of them, you know, if they're like commits to like a different provider or something like that, we don't, you know, really test those. But any commit to like core or anything like that, we do check those to make sure that they don't affect performance.
And then another question is, what Git repository is being used for the work?
The Git repository that we use, we have our own internal fork of Libfabric. And as we, like I said, we have our kind of our weekend validation. We have a CI on our commits, and that takes about an hour to run. And then we have a larger validation cycle that runs weekly. And assuming that looks good, we will upstream to Libfabric, OFI or OFI main on either Monday or Tuesday is the plan.
Okay, cool, thank you. Any other questions? We have a few minutes before we take our break. Okay, well, thank you very much, both, Tim. Oh, I guess we have one follow-up question from Raghu. What happens to the PSM2 provider once the OPX goes GA?
It'll still be supported and maintained. I guess for the near term and for the long term, I don't know, but it's not a big stretch to support it and maintain it right now. So I don't think it's going to go away.
Okay. And there's another question just popped up. With the performance graphs, was Intel MPI directly using PSM2, or was it using the PSM2 provider?
It was directly using the PSM2, and it's also important to note that was a build of Intel. Those numbers are generated with a build with the Intel OpenMPI one API provided PSM2 provider and Libfabric and MPI, and the OPX numbers were generated. So that's probably, I think that's compiled with ICC, and the OPX numbers are generated with GCC. So it's not exactly an apples to apples comparison. And if anything, OPX would get a little faster if we compiled it with ICC, I think.
Very good. Very good. Okay. Any other final thoughts or any other final questions from anyone? Okay, so we are going to take a break between 11:30